pattern. Dr. Wu, the floor is yours. Okay, thank you. Good morning, everyone, and thank you for getting up early for this talk. So today I would like to share some of the recent research from my group on the urban effects on cloud patterns. So historically, we have more literatures on urban effects on precipitation, but cloud actually play an equally important role in the urban hydrometeorological cycle. And actually, satellite remote sensing could be a really good resources to investigate this phenomenon. So since our late 90s, satellite observations, including sensors from AVHRR and MAVIS, as well as MSG Savory, has been unveiled some of the urban cloud anomalies, and you can see those patterns. For example, 10 years ago, my papers are showing Houston have been less clear compared to their surrounding areas. And recently, Thuy has also showing London and Paris have also summer daytime cloud enhancement. Also, she mentioned that likely is attributed to the surface heating. And actually, there's many passive ways that can contribute to the urban cloud modification patterns. Firstly, the strong surface sensible heat fluxing can facilitate development of boundary layer. Those strong convective uplift force can help to move the available moisture to the upper boundary layer. In addition, the urban rural secondary circulation can help to bring some transport some moisture from the wetter rural surfaces in non-arid region. But we also know it also highly depends on the conditions in the climate backgrounds, whether there's a right balance between the moisture and also the energy to help the cloud formation regionally. And also the rougher urban surfaces can help enhance the turbulence, then modulate the convergent process. The last but not the least, and also the emission of urban pollutants provide abundant cloud condensation nucleases that actually influence the cloud life cycles. And all those processes may play different roles in controlling the cloud patterns, including their spatial patterns and also temporal frequencies. So here in this particular study, we're using the 2 decades, 18 years daily cloud layers from MODIS onboard Aqua to characterize the cloud pattern over about 450 Kernes, U.S. urban areas. And so the city generally distributed within 3 major climate backgrounds: cold, temperate, and arid regions. And also later we grouped the city into different categories, including inland coastal cities and also cities in mountains. Those latter 2 groups also has been interacting with local strong mesoscale circulations or regional circulations, including land, sea breezes, and the mountain valley breezes, so that we have a separate group to assess that. There's a sub-region zoom in kind of a map and showing the cloud occurrence composite for over 18 years. And definitely from this region that you can see the urban signals about the cloud occurrences actually pretty clear. And so here we're using 2 indicators to characterize the local cloud patterns. First is we characterize the spatial anomalies and using the urban signals and also the background references, where we create a buffer that trying to exclude the impacts from any downwind cloud enhancement due to the windy conditions that contaminate the reference background. And also we count the frequency of the cloud occurrences at the daily basis for 18 years for individual month. And so that allows us to get a little bit better understanding of the temporal characters of those phenomena. Using those two set of indicators, we're trying to better understand is to address those two questions. Firstly, how do cities modify the local cloud pattern? And secondly, we're trying to better understand how the regional climate and the local urban features that can modulate their diurnal and seasonal patterns. So let's take a look at the national average urban cloud spatial patterns. This is the national average seasonal variation. The red line indicated the daytime, which you can see a two peak, like a double peak patterns. In the summer, winters, across corners have showing cloud enhancement for both winter and the summer. And for the nighttime, they only have one peak that mainly showing strong enhancements and during the day, during the warm seasons. Let's zoom in the summer. You can see generally the nighttime signal is almost as double in terms of magnitude compared to the daytime effects. The spatial pattern here, the dot size and the color indicate the spatial anomaly, red indicate the enhancement. Over 60% of cities is showing wide presence of enhancement, mainly distributed east side of Rockies. And also, you can also notice a little bit here is that in the area region, the actually is a little bit clear over cities. And the nighttime phenomenon, it clearly is enhancement is more more prevalent over the regions, and the largest enhancement present in the cold climate regions, which generally distribute the northeastern of the U.S. and the west coastal areas. So this is showing the temporal frequencies of the urban cloud enhancement. The red indicates more than 50% of time showing enhancement. Blue is showing less than 50%. So that's generally give us an idea. It's more than 50% of cities for day and night and showing actually frequent cloud enhancement over summer So, but there's also the patterns are not identical, and you can see there more. They also have cities that showing less frequent enhancement, but overall, they has to have a strong spatial signal to have a long-term positive signal. So generally, even the city have less frequent, but they can have a very strong spatial anomalies. And in the winter, we have observed a much weaker signals, but very contrasting patterns. For daytime overall, they have enhancement, and for nighttime, actually, cities are showing much clear. And this is in terms of spatial patterns here, the most of cold regions are showing a little bit more enhancement, and also the arid region. For the nighttime, about 50% are showing reductions, and which is quite different from the summer patterns. Next is because of those cluster patterns that we have observed previously, also show the regional variation that we have identified. So here we group the city into inland, coastal, and mountain city into mountains, and to do the attribution analysis in statistic model. Here is results for the inland city. Generally, we have showing the mean temperature and annual precipitation that represent the backgrounds that have indicates a strong control on the cloud, urban cloud anomalies. And city size and also the surface heating have strong control on the nighttime enhancement in general, which is positively correlated. Also, here we also confirm the earlier study in London that surface heating also positively, strongly contribute to the daytime enhancement. So in here is a winter pattern for inland cities. Here also climate region has showing much strong control, but daytime we only see the surface size, the urban size in log scale, and surface heating only can explain for daytime enhancement, but not the daytime reductions. And so this is a summary of different factors that control for diurnal and seasonal patterns. So using this as the references that we can compare the coastal city results. So the blue lines here indicate the coastal city patterns, which generally follow the inland cities, but with a weaker summer enhancement. And for the nighttime, they also generally showing strongest cloud enhancement during the summers. So for summers, the regional energy and the water availability interact with surface heating and under the influence of land sea breeze cycles, which could actually explain the summer patterns, but not for winter. Also, city size seems not quite relevant for this case. And the last, in the mountain areas, which is as for daytime patterns quite unique because there are no summer peak of enhancement anymore. So only have the enhancement signals and observed in the winter. And for nighttime, that generally follow the inland cities with a strong enhancement in the summer, but with a little bit weaker signals. Here, we only identify the local climates actually matters for the summer, but the other factors seems quite inconclusive for the mountain regions. It's relatively complex. To summarize, and so this is the first of a large region observational study and trying to showing that the common phenomenon for urban cloud enhancement even in smaller cities and during the warm months, and also the regional climate interact with city actually play quite an important role in control the seasonal cloud patterns, and also urban property surface heating have larger influences on the summer cloud enhancement. And also, I want to highlight the implications that showing the strong nocturnal cloud enhancement that could actually contribute to the nocturnal urban heat island effects by reducing relative cooling. That can be a possible source, but also depends on the cloud type, height, etc. But generally, compared to traditional discuss of the surface property impact, this can be a potential contributing factors. Okay, there's definitely caveats, but this topic, I think there's a lot of aspect that can be further investigated, and so I'm open to any question that you may have. Thank you.
Thank you, Dr. for your great talk. Do anyone have a question?